Consumer group in Apache Kafka is a very smart design choice, and I don't think I gave it the right amount of time discussing it in the Kafka course, which I talk about it right here. So I want to make another video just to tell you about what is consumer group and how powerful of a design this thing is to solve interesting problems, to solve like 4 problems or give you 4 benefits or even 5. I have a list around here. Actually, 5 benefits. Sheesh, that's pretty good stuff, right? So how about we jump into it, guys? So guys, if you're new here, my name is Hussein and I discuss backend engineering in this channel mainly, right? So if you like this stuff, consider subscribing to my YouTube channel. I have the same exact thing as audio form on my podcast. I'm gonna reference it below in the pinned comment on the comment section. So you go and listen to the podcast. Some of you complain that, hey, your videos are too long and I don't have time. So just pop up your earbuds and listen to them while in the gym or just working out or doing anything, right? So just listen in the background. So I think that's what I do. I listen to podcasts all the day, and I listen to YouTube videos, but I just minimize them because I don't watch most of the videos. I just listen most of the time while I do like daily stuff. So how about we jump into the consumer group, guys? So Kafka's design choice is very interesting. And at first was very confused about this concept, right? So what is a pub subsystem? What is a queue, guys? Right? So you have a publisher, okay? And you have the consumer that want to consume things. For the longest time, we said it's a bad idea to connect the consumer directly to the publisher because you don't want awareness. Coupling is bad. Coupling is the worst thing, right? You want social distancing in computer science. We don't like things to talk to each other. We want everyone to have social anxiety in computer science. That's the rule of thumb. Avoid coupling as much as possible. So we don't want things to know about each other. So we invented this idea of a broker in the middle. So it's okay, publisher, go and put your stuff there, and consumer, you can consume from the same thing. You don't really care where this message came from. You shouldn't really care. Just you subscribe to a certain topic, channel, whatever you want to call it, and then we're gonna deliver the message for you. How do we deliver it? It's a design choice. Kafka does it differently. RabbitMQ does it differently. Redis does it differently. I think Redis and RabbitMQ do it the same thing, but a little bit of a slow change. But it's backend engineering is awesome, guys, because there is so much stuff you can tweak a little bit of a thing to fit and suit certain use case and design criteria, right? There is no one fit all, right? This is not a t-shirt. You cannot fit anything in anything. You have to design your software so it fits a certain use case and hope that it solves your use case first. And you're gonna hope that a lot of people have the same problem as you. All right, so that's what you do. I'm not gonna go through the communication model. Maybe this is another video. But the consumer here is very interesting because if I consume a message from this partition or this topic, right? These topics, how do I streamline? I want this message, this topic messages to go as fast as possible. So if you have every consume one message at a time, you cannot parallelize this thing, right? So Kafka came up with the idea of partitioning, which is not something new. We know it. We call it sharding in databases, right? It's just the same concept. It's just now you are different, like you have 3-4 partitions, right? Let's say partition 1 is messages that fits this criteria. I don't know, from A to N, right? And this partition 2 is this, right? It's like indexing is very similar. It's just partitioning. You're partitioning your thing in disk, in memory, whatever it is. So now this consumer is aware of this partition. So, okay, you read from this topic from this partition. You read from this one from this partition. Right? And you can start doing and doing all that stuff. You read all that stuff. That's okay. And here's the thing. In messaging queues and in messaging systems, we have 2 models, PubSub and queues, right? Queues is if you have one message, right? Once this message is out, nobody should ever see it again, right? if this message has been read and committed, right, that it has been read, because that's a very important discussion, right, then we can mark it as read, right? RabbitMQ, I believe they pop it out of the queue. Kafka keeps it in the topic or the queue, and then you can seek back and read it if you want to. It's just set positions. Now, if you go back to the consumer, you can essentially have this model as a queue, right? Or you can have another model where a message, I want this message to go to everybody. Let's say you're uploading a YouTube video, and this video need to be compressed. This video need to be checked for copyright infringement. This video needs to be, I don't know, made into different formats. Move 1080, 420, right? 4K, whatever these formats, so they can be consumed in different formats. So these are services, right? And we can call them consumers, but the video itself, which is the message, need to be delivered to all of them, not just one of them. Otherwise, we're gonna. So a queue is not really a good idea here, right? Because the moment the copyright system pulls the message, which is the video, then the others cannot see it. We don't want that. So we want a pop-up messaging system where it pushes or pulls whatever the communication model to the rest of the systems, right? So that's what we want. So we want to support both. RabbitMQ does it differently. Kafka does it differently. Kafka does it with something called a consumer group, right? It's always like this with me. I take 7 minutes to explain the topic of the video, but I kind of flirt for the whole video. All right, guys. So consumer group. What is consumer group? So if here's a definition of the consumer. A consumer can only consume a certain partition, right, in a topic. You have to tell me if you're a consumer alone and you don't have any concept of a group, then by default you have your own group. There is no Ronin, right? It's not samurai. It's not Japanese era, right? It's like you cannot be a Ronin swordman, right? You have to belong to a group, and this group is yourself. It's just a default group, whatever. It's just your own unique group. Right now, if you want to consume the message, right, then you can be able to consume a partition. So you have to be aware of the partition, which is a little bit ugly. If you wrote some sharding logic at the back end, it's ugly. We try not to do that stuff. We should not be aware of shards. We should not be aware of partitions when it comes to sharding, right? That's why Vitess came in and solved our problem for us in the backend, right? And I still need to talk about Vitess, which is Vitess, Vitess, I think, SEE, right? I'll put it in the screen. But yeah, here are the rules. Let's say I have 3 partitions, okay? And I have a consumer group with no consumers, and then I add one consumer, which is a process. Think of it as a service, anything, right? In the consumer group. By default, this consumer will be responsible for all partitions. By default, it will just be overrun with all the partitions, and that's fine, right? Because the rule here is each partition must belong to one and only one consumer. The partition can only be read by one consumer in a group, right? But the partition cannot be read by 2 consumers in the same group. It's impossible. That's the rule, right? So now you have one consumer in the group. If you add another one, then they start balancing the group. This is called the balancing stage. So if another consumer joins, so we have 3 consumers and 3 partitions, that will be an even, right? So every consumer will have a partition itself. If you have 4 consumers, then you don't have enough partitions. So sorry, maybe the 4th partition, the consumer will not do anything. I don't really know what happened there. So yeah, if there is anyone who knows Kafka and what happened, and if I add another consumer or no enough partitions, what happened really there? I'll be interested to know what happened. So that's how you do a queue, right? If you want to do a queue, right, just add all the consumer in the same group, and by default, every partition will be consumed by one and only one consumer. So, and once that consumer reads that message and commits that it read, you're done. you can move on with your life, right? And just do something else. So, and that message will never be consumed by anyone else. So that's a queue. That's what we want, right? That's a queue. Queue on pop it, you cannot read it again. So that gives us a queue. What else it gives us? It gives us parallelism, right? Because I can parallelize my consumers to read all these partitions at once, right? So the more partitions, the more consumers, just read them in parallel. So I'm reading technically a topic, right? I'm reading videos, and these videos are partitioned into partitions, and I'm reading them in parallel, which is powerful concept. And another thing that it does, the consumer group, is it removes the consumer awareness of the partition, right? Remember, when we read a consumer to a partition, we need to know what partition we're reading, which is kind of ugly, right? Consumer group will remove this thing, right? So once you add it, we're going to take care of it. We will assign it for you. Kafka will assign everything for you, and you'll be happy. So the rule for the consumer group, one consumer can consume multiple partitions, but the partition can only be consumed with one consumer only. So it's like an aggregation relationship. But remember, each partition must be only consumed by one and only consumer, right? Yeah, I don't care if that consumer is reading other partitions. That's right. As long as me as a partition is only read by you, sir, you can only read that partition, right? You cannot read, no one else can read me as well, right? And once I read, this partition is invisible to any other consumer. That's very important to achieve the queue system. So Hussein, this is how we do a queue, right? Put all the consumers in one group, and the topic is now queued almost, right? So like every process, we will guarantee that every consumer will only get one message, and the message will not be duplicated to anyone else, which is awesome. So how do I achieve a pub subsystem where I want the video to be published and then consumed by many other services so they can do this stuff? Doesn't have to be video, by the way. You can think of any idea where a pub sub versus a queue, right? A queue example is a job, right? A task execution, an asynchronous task execution system where, hey, here's a task, I want someone to execute it. You ideally want only one process to execute the job. You don't want two, otherwise it will be a waste, right? Once someone executes the job, you want to pop it off the queue, right? That's the idea. Versus a pub subsystem where, like a video, right? I publish a video, I want these services to start consuming this video and start doing its work. Everyone should get this concept. So that pub sub versus a queue. All right, awesome. So now, how do I do a pub subsystem in Kafka? Guys, how do I do that? Well, it's very simple. Don't put it in a group. Put every consumer in its own unique consumer group, and just like that, if you subscribe to the topic, you will be able to read multiple partitions. You'll be able to read the same partition. Who cares? And that now the uniqueness, the position of the partition, where is this group at, is at group level, right? So let's say you have a one partition and the partition's position is 0, right? And now consumer group 1, consumer group 2, consumer group 1 can actually read the same partition 0, and it's just to start moving the position to position number 3. So it's like 3 messages. Consumer number 2 is still at position number 0, so it didn't actually read the messages, right? So that's how the Kafka works. It's just literally moving the position into another level, right? Instead of physically removing that. That's why you can stream partitioning. You can read old messages. You can keep them forever if you want. You can go back and read them. You can do all kind of stuff. There's one problem with the consumer group that I never thought about, and it's called head of line blocking. We had the same problem with HTTP. We had the same problem with HTTP and TCP, HTTP 1.1 with TCP, right? Because with pipelining, to be specific, like if I send multiple requests on the same TCP connection, those responses should come in the same order, and as a result, you get head of line blocking. So that, let's say, if request number 3 finishes before request number 1, then request number 3 unfortunately have to wait before it gets sent. Response number 3, that is, right? has to wait before it gets back to the for the user. Otherwise, we cannot send it. So head of line blocking. We have the same problem with HTTP2. However, it's at the TCP level, right? The same problem because we have streams in HTTP2. We multiplex request on each request on a stream. However, TCP try to be smart, right? Because packets are also have their own sequence number called SYN, SYN-ACK, all that stuff. We talked about that, right? In the TCP handshake. So TCP packets also are synchronized. And if packet number 11 arrived before packet number 3, then the TCP stack will block you until everything before that arrives. Despite packet number 11 belongs to stream 10, right? And packet number 3 belongs to stream 1, which has nothing to do with each other. They technically can be served statelessly, right? That's the idea, right? So everyone has to be served by its own. Why do we wait? So this blocking has been fixed in Quick and HTTP3, and Kafka has the same exact problem with the head of line blocking, because you can have a partition, and since a partition can only be, well, one consumer, guess what? This is a little bit different. The consumer, if you got a slow message or the consumer somehow is overloaded, we don't know why, but it will start slowing down the execution of the partition 1. Although partition 2 and 3 are so fast, they are just pumping messages. Your partition 1 is stuck, and the messages are getting accumulated and not being consumed because either the message is bad, the message for some reason, that particular message is expensive to consume, right? And I don't know why. If you're asynchronous, you shouldn't be a problem, to be honest, because all right, I got it, I'll take care of it. But sometimes you want to tell the consumer that, hey, I'm not going to commit that I read that until I finish it. It's the whole problem with exactly once guarantee, with exactly at least once guarantee. All this people take PhDs in this stuff. This is complex topics, right? So if you think this field is done, no, you think again. We are solving so much problems. You can just pick one problem of all these problems and try to get better at it. But as I always say in this channel, right? You gotta learn the fundamentals. You can't just learn Kafka and don't know anything what happened inside Kafka, right? It's up to you if you want to just consume something without knowing it's on the book. I mean, I drive a car and I don't know how it works, to be honest, right? But I'm not a mechanic, right? If I am a mechanic, then I should know. I am an engineer. I take pride of any software that I use. I better know how it works, right? You can argue and disagree with me, but that's my opinion, obviously. If I'm going to use a technology, and I'm an engineer, I take pride of my work. I need to know how the stack works inside and out, right? To a certain level. After that, I might not care. Maybe, and this is very interesting, a little bit off topic, but guys, I think you're gonna appreciate it. It's part of the collateral knowledge. 3 years ago, when I started my journey to kind of learn more about backend engineering, software engineering, and just learn everything, and I talk about it in this channel, I reached a stage where, okay, I know about this concept, right? But I was afraid, or not really afraid. I don't want to dive deeper because my understanding, what I wanted to understand, is only this level, right? I don't want to go deep into that. And an example of that, for the longest time, I didn't know how TCP works. And I didn't really care. And that carried me so far until I reached a stage. I was like, you know what? If I need to understand how proxies work and why we're getting overwhelmed at the back end of the proxies. I need to understand how TCP works. So I spent some time and learned this TCP. But guess what? That drove me to learn more and more technologies, and that's how you learn. And you're gonna reach a stage where you say, okay, and that's what people tell me. So okay, then don't use JavaScript and don't use C#. Use assembly to code everything. That's just a BS argument that I don't even know want to reply to. Yeah, I will use newer tech all the time as long as I understand how it works. I will not use something as a black box. It's just okay, oh, it just does this. Some people are okay with it, some people are not. I'm gonna leave this question to you. What do you think about consumer group? What do you think about Kafka with my messaging queues? Do you think we're overcomplicating things, or do you guys looking for a simpler solution out there? Let me know in the comment section below. I'm gonna see you on the next one. Make sure to subscribe. Check out the podcast because a lot of people are like, I notice a lot of people actually coming to the channel from the podcast. I was really surprised. So thank you so much for everyone who listens, for everyone who watches. I really appreciate you. Thank you so much. You guys see you on the next one. You guys stay awesome. Goodbye.